Now we will be discussing the mechanism of action of alcohol. And for that, we need to have a look at the anatomy of the brain. The first system to be affected is the reticular activating system, and in that the main nuclei that are affected are the Raphe nuclei, which are located in the midline throughout the brainstem within the pons, midbrain and medulla. The majority of the neurons located in the Raphe nuclei are serotonergic. Rostral Raphe nuclei appear to be important in various bodily functions, including pain sensation and mood regulation. These reticular activating system nuclei communicate with the suprachiasmatic nuclei, contributing to arousal and attention. Now, what does alcohol do? The first region affected is the reticular activating system, resulting in the disruption of motor and thought processes. Suppressing the cerebral cortex causes a variety of behavioral changes. Which specific behaviors will be suppressed and which will be released from the inhibition depends on the individual himself. In general, complex, abstract, and poorly learned behaviors are disrupted at low alcohol concentrations. Now, the reticular activating system, what neurotransmitters play a role in all this process? Number one is dopamine. It is an upregulator. In individuals using alcohol, dopaminergic activity in the nucleus accumbens is responsible for much of the drug craving effect and the addictive behavior. Next is serotonin. In the central nervous system, several 100,000 serotonergic neurons lie in or in juxtaposition to numerous midline nuclei in the brainstem, that is the Raphe nuclei, from which they project to virtually all areas of the brain and the spinal cord. So that is how the entire reticular activating system is affected by alcohol. Serotonin is involved with mood, emotion, learning, memory, personality, affect, appetite, aggression, motor function, temperature regulation, sexual activity, pain perception, sleep induction, and other basic functions. However, again, important thing to note here is that serotonin is not essential for any of these processes, but it only modulates their quality and extent. So dopamine and serotonin are the upregulators, and in contrast to that, gamma aminobutyric acid is one of the two main inhibitory neurotransmitters of the central nervous system. And out of these, there are two main types of GABA receptors, of which GABA A receptor is mainly important, which is responsible for the influx of the chloride ions, and it attaches and it opens up. GABA receptors, they open up and they allow the influx of the chloride into an hyperpolarization of the neuron. Now, what does alcohol do here? Alcohol comes and gets attached with the gamma aminobutyric acid A receptors, and it keeps that channel open for the regular influx of the chloride ions for hyperpolarization of the neuron, and inhibitory effect is thus progressed. In contrast to that is glutamate, which is the main excitatory neurotransmitter in the central nervous system, and it is an immediate precursor to the main inhibitory neurotransmitter GABA. And hence, the balance between the glutamatergic neuronal stimulation and GABAergic neuronal inhibition is essential to maintaining the normal central nervous system function. Now, this function is altered with the alcohol ingestion. What happens is that the glutamate receptors, they are responsible when they open up, there is an influx of the calcium and the sodium ions. These cations, they inflow inwards, as contrast to the chloride ions, which are the anions, which influx into the neuron when the gamma aminobutyric acid receptors, they are kept permanently open by attachment of alcohol. But what alcohol does here is exactly opposite. It attaches with the glutamate receptors and it blocks the pathway. it closes the pathway, it reduces the influx of sodium and calcium into the neuronal part, and thus it inhibits the excitatory effect of glutamate. So this is the mechanism of action of alcohol at the neurotransmitter level.